In this video, we're going to look at the last way to express inverses. But in order to do that, I just kind of want to show you an example. So let's say, for example, I take a function, which is, let's say, f of x, and let's say I call it x plus 3, okay? I do f of x is equal to x plus 3. And if I do the inverse, okay, and you can trust me on this, you can do this by yourself if you wish, but f inverse of this very function, I've already done it beforehand, is actually equal to x minus 3. All right, so these functions are inverses of each other. So what I want to investigate is what is f of f inverse of x. So let's take a look at that. So that's f of, obviously, f inverse of x here. F inverse of x is simply x minus 3, so that's f of x minus 3. And that's equal to something plus 3, and that something happens to be x minus 3, and 3 minus 3 is equal to x. All right, so f of f inverse of x in this case is equal to x. Let's do the opposite. Let's do f inverse of f of x. Let's see what that is equal to. So f inverse of f of x, that's what that means. So f inverse of x plus 3, here's x plus 3, and I'm going to take this x plus 3 and plug it in here into the f inverse function. So it's something minus 3, and that's equal to x plus 3. So plus 3 minus 3, well, I'm just left with x, and there we go. So now here's a very, very interesting thing that we see. This is the first time that we've seen where if I switch these two, this is equal to x, and if I switch these two, that is also equal to x. In other words, in this case, f of f inverse of x is equal to f inverse of f of x. This is kind of like, imagine if I called this g, right? So imagine that, let's say I called this function g right here. So you don't have to do this. I'm just doing this to illustrate something. F of g, and let's say if I erased the f inverse here, and I called that g. This is the first time that we've seen where f of g of x, which is equal to x, is equal to g of f of x, which also is equal to x. So in other words, these two are equivalent. I'm going to erase this g and go back to write down what it was initially. Actually, you know what? I'm going to leave it in green because I like that. So this is going to be f inverse over here, and here is f inverse over here. So what the interesting thing to note is that this thing sort of maps to x. And what this means, it doesn't simply mean x, it means that, where's the pen? There we go. It means that it's sort of mapped back to y equals x, right? Simply, when something equals x, it just means y equals x. And we are familiar with this notation before because we've seen it before. I'm going to go back a few slides where, so right here, so what this means is, let's say, for example, if you recall this graph from before where I had a function and then I had an inverse function, and we showed that the inverse function was a reflection across this line, y equals x. So imagine if I have a function f of x, and instead of this x, I compose it, I do a composition of function of the inverse. I map back right onto this very line. I basically come back to this reflection line, this mirror, if you will. And if I do the opposite, if I do f inverse and I do a composition with f of x, again, I'm going to map back right to this very line. So what does that tell you? That basically tells you that when f of some function is equal to x, or some other function of f is also equal to x, whenever a function of another function is equal to x, it means that these two functions are inverses of each other. So let's write this down formally. So, for example, so if I say if f of g of x is equal to x, what it means is it maps back to the line y equals x. So anyways, if this is true, if this statement is true, then f and g are inverses of each other. And by the way, it doesn't have to be in that order. We can also write another statement, which is like this. If g of f of x is equal to x, then the same thing happens. Then f and g are inverses of each other. All right, so I hope that makes sense. This is actually a very, very crucial statement. This is the third way that we're going to sort of describe inverse functions. So the first way is simply saying inverse. The second way is saying, let me go back here. The second way is saying right here that it's reflected across y equals x. A line is reflected across y equals x. And the third way is saying that if the composition of two functions is equal to x, then we automatically know that these two functions are inverses of each other. In the next video, I'm going to just show you an example of how we can implement this. So I'll see you there.